Hello, good evening.
Good evening, everybody, and welcome to another live session. We're going to wait for a few minutes for others to join in, but please, if you know your colleagues that are supposed to be on this call, please just nudge them, kindly nudge them so that they will join the call and let them know that we've started. I'll also check if our speaker is already on the call, and then we'll start by 5:05. Okay, I think our speaker is here. We'll just wait for a few more minutes for other people to join. Welcome, Kudus. I can see you're already on the call. We'll be kickstarting the session in by 5:05 on the dot. So we're just trying to nudge others to join in.
Oh, okay. Thank you.
Okay. Good evening, everybody, and welcome once again to our monthly webinars. And in today's webinar, we have someone who's actually a community person, actually, and very, very knowledgeable in this topic, right? We've asked for feedback from the community members, and a lot of people said they wanted technical topics. They want something that hands-on, something that they can practicalize, or they can see someone actually practicalize it. So we're going to be kickstarting it shortly. I'm just going to introduce who our speaker is. And by the way, if there are some of your colleagues that should be on this call, please reach out to them, especially data scientists. I'm very, very sure that this session will be beneficial for everybody. Trust me, AI is actually something that's taking, you know how the internet took over the world. It's looking like that's how AI is beginning to take over the world. So I feel like this session is going to be very, very helpful for everybody, regardless of the field in data that you actually belong to. And our speaker today, so the person that will be taking us on this journey, his name is Abdulquddus Ajibade, and he's an AI and ML engineer, a researcher, and a physician in training, focused on AI-driven health tools, ranging from language models to intelligent systems and agents to improve healthcare access across Africa. He also leads AI at Help Mom, where his work has impacted over 200,000 lives. And he's also the co-founder and CTO at Open Health, a digital platform advancing preventive care. He's a published researcher on AI in medical devices, imaging, and language models, with recognition in top journals and conferences. Abdulquddus regularly speaks and facilitates sessions on health AI globally, which is why we also have him here. And he also co-founded Medics in Tech, mentoring health tech professionals. Now, while he has contributed to AI in law, insurance, and finance, his mission remains transforming global healthcare through technology. I would expect that I'm seeing some reactions now, because this is like a huge profile. This is like a huge profile, and we are so honored to actually have Kudus in our midst today. So I'm just going to let him do us the honors of, sharing his screen, taking over the screen, and just kickstart the session. Please, before it would start, I want to make sure that we maintain decorum. Every mic stays muted, and we just pay attention. When you have questions, just keep them until it's done. We're going to take a lot of questions. But thank you so much, Kudus, for honoring our invitation, and we're glad to have you. You can take it off from here.
Thank you, Tina. Thank you everyone for joining. So, like she mentioned, Abdulquddus Ajibade, and I'll be taking this session, this practical session. And since it's a practical session, that means there will be hands-on, and we expect that we have our laptops. So please, if you have your laptops in front of you and you are ready to do some coding, can you just drop some reactions so you can see? Okay. Can only someone pressing? All right. So, okay. All right. Okay. So, let me just share my screen right away. So please, at any point in time, if you can't hear me, please, you can just let me know. So I'll be sharing my entire screen actually. So can you see my screen?
Yes, your screen is up.
All right. Okay. All right. So the session is on building AI chatbots with Langchain and RAG. By RAG, I mean retrieval augmented generation. I'm very sure by now we probably have seen a lot of these words being used online. If you've been on LinkedIn, I mean, we had a lot of LinkedIn RAG influencers for some reasons, best known to them anyways. But yeah, RAG is very interesting and it's very important, and it has really transformed a lot of development in the world of AI engineering. Thanks to RAG, like a lot of people have been able to build really amazing solutions. So the essence of this is to build a conversational agent or a conversational chatbot. And what do I mean by that? It means you can ask a question and you expect it to give you a response. So that's a conversation, right? So, and it's not only a conversational chatbot, it's not a generic one. It's going to be a personalized one, such that you expect it to pick the responses to your questions from particular documents, and to be able to do justice to the questions you're asking. So, and why exactly do we even need RAG? Why do people talk about RAG? Why are people building with RAG? So before RAG, when LLM came, and let me say when LLM became popular, because it's been around for a while, but when it became popular and people have been using it to build stuff in AI engineering, either through the APIs or through the models themselves. So it's always been a thing of, oh, how do we prompt this thing? How best can we prompt it to get a response, right? And it's always based on the knowledge of the models themselves. So whatever the model seems to be the answer is what it's going to give you, right? Fine, it's really been the development has really been really good, and the responses have been great these days. Now we have a lot of very intelligent models, but there are cases where you want to ask questions that the model's generic or base knowledge would not be able to answer the questions, especially when it's even a personalized, it's even something specific to what you're doing, right? Say for instance, you are working in a company where you have the data of your company, right? And um you have customers data, and you want information from those customers data. You don't expect the generic model to have those information, right? Because the information the LLM has actually are the things that are being trained with. Do you understand? So, well, there's a lot of um, let me say explanation to that, because generative AI means is then going to use that to generate new information, not the conventional machine learning we are used to, where it's always garbage in, garbage out, or information in, information out. You understand? So this time around, generative AI is actually going to generate new information, but most times it's always based on the knowledge it has. Okay, so, and that means you don't expect to ask ChatGPT, for instance, about something that happened in your company yesterday, because it does not have the information, right? So it's probably just going to hallucinate. One thing is it's used to do, but these days, anyways, it is going to tell you it does not have the information. Before, it's just going to tell, just like hallucinate, but they've been able to control that to a large extent. But if you are working with the model, for instance, locally, right, and there are some parameters that are important to us when building with those models, and one of them is temperature. And what we used to do is to actually control the degree of hallucination. And what do I mean by this? Is to control how it just hallucinates and thinks of, like, formulates a response to the question just for the sake of answering the question. So, and setting a high temperature, for instance, means you want it to, to answer the question however way it can, even if it's going to be lying. But setting a low temperature means it tells you that it does not know if it actually doesn't know. So, well, that's also important in this, because it's also a important thing when we are building with artificial intelligence, to always take control of the temperature. So I will probably talk more about that when we get there. But I was trying to differentiate the normal generic models or generic AI from this specific method, where it answers based on your document itself. So the architecture of this retrieval augmented generation is just based on, like as the name implies, retrieval, augmentation, or let me say retrieval and augmented generation, right? So what does this retrieval mean? So, and let me just give you the brief overview of the whole process itself, because like I said, it's a practical session, so I would want to just run through this briefly. But if at any point in time you want me to re-explain, I can do that, but so that we can be able to build something at least before we leave this session. So I'll try to be brief as possible. So what happens in retrieval augmented generation? Actually, like I would divide it into about three phases, or say two major phases. And the first part is you storing your information somewhere, right? And the other part is you getting back the information. Do you understand? So well, it depends on, like, this is the commonest thing, and it depends on how you intend to build your architecture, right? But for this basic one, so the way it works is that you would have your data, for instance, and when I say data, I mean your documents, right? It could be your PDF, your whatever data format, really, CSV, TXT, and Markdown, however way you want to store your data or your text, right, or your documents. So you have that in your folder. Then you
Sorry to cut
yeah.
in. I think the Google Meet this thing is blurring the some of the text, so people can't really see some of the text. So if you could just minimize the Google Meet pop up.
Oh, sorry. How about
Thank
now?
Yes, better.
Oh,
Thank you. We can
sorry.
continue.
I didn't notice that. Okay. Um. All right. So, like I was saying, so that's the part where you have to store your information, right? But I'm very sure we are familiar with the normal traditional way of storing data in database, right? But now we need to talk about what the different kind of database we are using in this case. We have the scalar and the vector database. And just from our basic knowledge of what scalar and vector would mean. So essentially here it means that you want to add some level of semantics to your database. And what do I mean by this? When you store something in a scalar in a scalar database, for instance, you are going to query it the exact way you're storing it, right? So and that means if you want to get something from column 1, row 2, you have to specify that this is where you want the information to come from. Okay. And it does not find it there. It probably just tells you it's not J at all. It can't find that particular information, or it can't find that, the normal SQL you are familiar with, right? But it's a different thing for the vector database. So in the case of vector database, it's not necessarily going to bring like the exact thing the way you stored it, right? It's going to bring the most similar thing to what you're asking for. Do you understand? It's able to understand the relationship between what you're querying and what you're asking for. Do you understand? That's the importance of the vector database. And you understand why this is important, because you might not know the exact thing in your documents. Because if you know what is there, so why are we doing querying in the first place? The essence is to build a knowledge base. Do you understand? And to assume that we don't necessarily know everything in our documents. Do you get? But you want to be able to query information that should be able to answer your question in the best way possible. So that means you cannot ask it the exact ways in the document. So you want it to bring the most similar response to your question. So that's the essence of using the vector database instead. That's why it is the best for this. So we have different kinds of vector database. Okay, so for the just a disclaimer, whatever technology I'm using here is probably just my own personal preference. I'm not promoting anything, but I'm a fan of Pinecone anyways. So there are other ones, probably because at the time when I was starting to like at the time when I was testing this vector databases, some gave me a lot of issues, but Pinecone has been good. And to a large extent, the free tier is nice. Okay, so I use Pinecone as my vector database, my go-to vector database, even in large production. So, and that's what we'll be using for the sake of this project, right? So that means the first part, like I said, is storing your data or your knowledge base or your documents in that vector database. So just leave it there, and would do something about it. So another good thing about that Pinecone vector database is that it is cloud-based. Okay, and that means if you are going to be using your own local vector database, for instance, you would have to be burdened with you have to like face the burden of hosting it or deploying it, especially if you are building to deploy in production. Okay, but the vector database, the Pinecone, this one is cloud based. So now the second part, which is the retrieval. of your information, and that is that you ask a question. So you don't want it to answer, you don't want the model to answer your question directly without going to the database. It's not as if it might be able, it might be a question that it can answer. For instance, you're asking what is HIV. It's not as if you have asked ChatGPT what is HIV, it's not going to, it's going to be able to answer by itself without, but you don't want, you want the information to at least consult, your knowledge base before answering. Okay, so that's the essence of this. So now when you ask the question, it goes to that vector database, it fetches the closest what's it called, result to a response to your question, right? Then it now does something with it. It now depends on what you're building. Okay, so you might want to say, oh, and the number of information is queries depends on what you specify. Do you understand? Because we would I'm coming to the embedding part actually. I should started from there, but where you're querying from the vector database is based on what you specify. So do you want it to query only the best, the closest or most similar response, just one, or you want to query the top three most similar response? You are going to specify that. I will show you where you do that in the code. So it depends on you. And sometimes the best, most similar one might not actually contain all the answers to your question. So probably sometimes you want to say at least query the top five similar or top five closest response to this question, right? So now that's the retrieval. Again, we might say, why not just release that as the response, and the user should just see that as the response to the question? No, because the reason why we can't just release that as response is because it's not structured in a way to answer the question. It's just based on the chunk of your data. It's just going to probably pick a paragraph in your documents, and if you read it, you know that, oh, this doesn't make sense to answer my question. So the augmentation part is that it's going to the LLM, right? The base model of LLM, let me say the large language model, right, is going to use that queried or retrieved document. It's now going to like augment it. You know what that means. It's going to kind of support it and then refine it in a way that is going to like answer the user's query. So, and that's why it's possible for you to ask a question like, what is HIV? And it's going to answer like, HIV is a this and that in a way that is reasonable. Okay, so, and that's why this whole process like come together, and every part of the system is very important. Now, the part where I skipped, the embedding part. So, and it's very important to mention this because it's also quite technical. And what we are doing exactly is that, you see, at the level of you storing the data in
Abdulquddus, we can't hear you.
like unlike SQL. Sorry.
Oh, you're back. You're back. We couldn't hear you for a minute.
Sorry, please, where did you miss me? Sorry. What was the last thing you heard?
It was just 30 seconds, so it was not. It
All
was
right.
not. Yeah.
Okay, so I was explaining what embedding means, right? So, and I said at the level of you storing your data, your documents in the vector database, you don't store it as the text like that. Do you understand? So you have to embed it. And what that means is that you're converting your text, your what is this, what is that, your normal natural language. You're converting it to a vector. Okay. So, and the vector is like a representation of your text in a I don't want to say number now because it's more than your scalar numbers that we are used to. So, and is a way to kind of add like a dimension to what to the text, and that is very important because that's how we are able to judge similarities. Do you understand? So it might be easier if you have a maybe a math background or a physics background. You might be able to grasp this easily, but for the sake of others, so not to be so technical, the basic meaning of this is that you want a kind of representation that is going to be able to make sure that a similar word to that can be recognized. So for instance, if you have three words um like come, go, and banana. Do you understand? So you know that come and go are kind of, although they have I mean CAN is far different from GO, right? So that you won't say, oh, probably is querying it based on the of the letters to themselves. No, that's not it, right? So the letters themselves are kind of like very different, but you see the meaning opposite words, they can be found in when we use a vector representation. So now this vector can now be in different dimensions. Okay, so and it is based on the embedding model. Do you understand? So you can have 768, you can have based on the embedding model you are using. So the reason why this is important is that is the same embedding model you are going to also use for your retrieval. Okay, because imagine me I'm trying to look for a very similar thing. Imagine me saying that I want to I want to store this English language, for instance. I want to store it in Roman language somewhere. Do you understand? So, and that means wherever I'm storing it is saying that I don't even know Roman now. Okay, let me use Yoruba. So wherever storing it, like I want to store this English somewhere in Yoruba. So it's saying that, oh, come, wa, go, law. Do you understand? It's kind of representing it like that somewhere. I mean, that's now I'm just like so that for layman explanation. So it's representing it somewhere like come, wa, go, law. Now, if you want to ask the question, you're not asking it a different language. You don't expect it to understand how to query the information. Okay. So even if it does, it's because again, even if it does query the information, it's not going to represent like what it should represent. So that means you have to query it based on the language you're using to store it. If you're storing it, it's English Yoruba. If you want to query back your Yoruba, then you ask in English. If you're asking in Roman, there's no way it's going to understand. So it's the same way. The embedding model you are using to store the information is still the embedding model used to retrieve it. So at your retrieval end, right? At the other end, now I see there are two, the storage and retrieval. At your retrieval end, you use that same embedding model. So it has the same dimension. Like I said, it's the same model. So I don't know if it has the same dimension now. You're using because some models actually have same dimension. So you don't say because they have the same dimension, I use the same model. No, you have to use that exact embedding model. So basically or majorly that's how the architecture looks like. It can look if this is the first time you are experiencing this, it might look quite technical, but it is simpler than I explained. Right. So because of time, I might not want to go too deep into it, but of course you can ask questions. But it's like very simple, okay? So so when you're done with all this, like if you're building to scale or you're building for production or you're building an app, for instance, of course, you don't want to put all these in a Google Colab or put them somewhere you won't be able to build out the app and deploy it. So most times you wrap this in an API, okay? So mostly RESTful APIs. So if you are from the Python background, probably you want to make use of Fast API, you want to make use of Flask or Django. But for the sake of this, we'll be using Streamlit. And the reason is so that we can have a front end to it. Streamlit combines both the backend and the front end. It has the RESTful API as well as the user interface so that we can be able to build something out. So that we'll be using. Um okay. The model we'll be using, the our LLM will be using is the Google's Gemini 2.0 Flash. Again, I'm not a Google ambassador, but because the API is free, that's why we are using it. Now, this embedding model also is a free embedding model. This is why I'm saying free. See, these things actually, if you want to use the good ones, like you have to pay for them, including embedding, including the model, and it's very important. You would see if you use a good model, you would appreciate the result you are getting. So, um, all right, I've explained most of the things here. Don't let me waste much time. Yeah, okay. One other thing that I might just want to explain here is that, again, we'll be using Langchain because Langchain is a framework that has most of these processes simplified. So, sorry, can you still hear me? Please let me quickly confirm if you can still hear me.
Yes, we can hear you. We can hear you.
All right, thank you. I hope I'm not too fast.
I think your pace is very good. Everyone is following.
All right, thank you. Okay, so what I would explain here is how we break, you see, the document. And this is also very important because it determines how you understand the querying. So you see, the document, you don't just store the document, if the document is in a PDF format, for instance, of 50 pages, you don't just take documents, bam, and go and show it to your vector database like that, 50 pages. Do you understand? So that means that anytime you want to query something, it's going to be querying the whole document, and that does not make any sense because you want to query the exact response to your question, not just the whole document. So that means we need to break the segments of the document into different segments, and this is well, okay, basically to break it into the different segments. Do you understand? Say, and to just explain briefly what the whole chunking thing mean is that, say for instance, you have a document of 10 pages and you want to break it into, you have to omit to answer this question, please, anyone. So you want to break it into okay, let me give you an example. Say if you have a document of 2 pages and I want to break it into sorry I want to break it into 10 chunks, right? If you have a document of 2 pages, I want to break it into 10 chunks. So the chunk size in this case now is going to be, say, let me use a simpler one. So if I have a document of 10 pages, right? If I have a document of 10 pages and I want to break it into 5 chunks, okay, I think this is easier. I have a document of 10 pages. I want to break it into 5 chunks. So a chunk size will be 2 pages. Does that make sense? Anyone? Let me see reaction. So I have to. But does that make sense? Can anyone unmute?
Yeah, people are reacting, but you guys can mute and let him know. So you're following.
Yeah. So I hope you get that. So if you have a document of 10 pages, you want to break it into 5 chunks. So the chunk size in that case is like 2 pages. Do you understand? So and that means that if you have a document of 2 pages, you want to break it into 10 chunks. The chunk size will be 0.5. Does that make any sense?
Yes.
All right. So that kind of explains what you see, and that is important because, like I said, you don't want to store so much information at once because one chunk, when you query, for instance, one chunk, and you want it to, like, you want the response to come in one chunk. So if that one chunk contains so much information, that can is like saying you want to ask what is HIV, and in that same chunk it has information about HIV, about diphtheria, about, do you understand? So it might not, while your augmentation model can try to help you like modify it and make sense, right? But again, it's a challenge to the integrity of your response. Do you understand what I'm saying? It's a challenge to the quality, right? So as much as possible, you want to have it in so much chunks, but now there's also a challenge with that, right? And these things I'm saying are just like for development purpose, like when actually building, for skill. So it's the issue with you having so much chunks is that it uses so much power, and it uses more extra resources. Let me put it that way. You understand? It uses extra resources. So, and it depends on your subscription for your model, your subscription for your APIs to be able to handle that. So, and those are the factors that actually affect what determines our chunk size, what determines, our document. We look at the model and we see the capacity. If you are using a free model, for instance, you know that you don't have so much options, if not, you'll be running into one errors or the other, right? So, especially rate limiting errors. Oh my God, if you have the experience, you understand how that was issues for people that were building for Lapo Lapo's sake. Okay, so yeah, so building with free resources can be really stressful, but for the sake of this project, I've kind of made it such that you, as much as possible, would not run into errors, about with rate limits and all those. So yeah, so let's quickly go into. Okay, I've explained most of these. Don't let us waste time, please. I've explained most of this. All right, so now let's scan this. If you are with your laptop, let's go to this. This is where the GitHub repo is. So, and again, we'll be making use of VS Code as our, or even if you don't have VS Code, you can use any, actually, sorry, any IDE, right? So, but if you have the way I structured the README for this, I mean, it uses VS Code. So, but you can use any IDE, any coding one you're used to. But if it's collab, might not work for this, right? And I intentionally didn't want to make it a collab thing, and because I mean, you don't get to use collab in real life, except maybe for learning sake, for research, but this is engineering, right? And you want to use something that can actually be used to scale. Okay, so that's why I'm making use of this method. So can I move from here? Do we have it? Can someone copy it and put to this chat so that I can move? Sorry, am I still being heard?
Yes, we can hear you. I'm just trying to copy it and put it on the chat.
Oh, okay, cool.
We can go on.
All right, cool. Thank you. So I mean, if you are there, then it should take you into this way. It will take you here. So this is the GitHub repo that contains the code. So it's very beginner friendly. So at your leisures, you can go through it so that you would understand everything. So we can't start going through everything now. It's quite, but I mean, it contains I added comments so that you can be able to follow through with it. Okay, so so now quickly, if you don't have VS Code and you have your laptop with you, let me see. Sorry, can I see reactions? If you don't have VS Code but you have your laptop with you, you don't have VS Code but you have your laptop with you. Okay, Ojo, Daniel, well, we have quite a number. Okay. So if you don't have any apart from collab, if you don't have any coding ID, I mean, and you don't use to probably write code on you don't have any coding platform at all on your laptop. Can I see reaction? Hey, okay. Okay, so that means you have more work to do. Okay, so actually, there are two things. If you are not able to follow through everything now, so the repo is public. You can always go there and follow it from the beginning to the end. And if you if you have any issues, you can always drop a message on the group so that you can be able to help. Okay, so but if you are lucky enough, probably you have very good network, right? So, and you can able to download this very quickly. This is the VS Code. You can download this very quickly. You can also follow this to set up your Python and your Git. So if you are lucky enough to do that, then that would be good. So, but if not, you can still follow us so that you can still grasp a lot of things. But if you have VS Code or you have a coding platform and you have GitHub and you have Python, so we are good to go. Are we okay? Can we continue? Can I see actions? All right, let's continue. So that's the first part of the setup. Okay. That's the first part of the setup. Now the second part is to get this my repo on your laptop. That's the second part. So if you're familiar with Git, that means probably on your you have Git already on your laptop that you work with. So you've done Git init before and you can now do the Git clone. Go ahead and use this. So, but if not, well, there is still something we can do. So, but you have Python. There is nothing we can do without Python. No. So, but without Git, we can still do something. But without Python, I mean, everything starts from Python. So please, you have to set up Python first. Okay, and it's very easy. If you have any issue setting it up now, you can just quickly let me know. But it's very easy to set it up. All right. So if you have Git again, like I said, continue with this, do your Git clone, then go to the CD to the folder. But if not, you can come here, come to code here. Okay, then download zip. Click on download zip. Come to code, click on download zip. You can see it's already helping me. Yeah, you can see now. So you have it downloaded. Okay. So then you now go to your folder or go to your what's it called, your explorer, right? And extract it. So when you extract it, you're going to see the folder. Okay. So now you can navigate to it on your VS Code or your coding platform. Okay, are we still together? Okay, reactions. Are we still together? All right, good. So so if you are there, if you are here already, then thank God. Let's continue from here. So when you are there, you are you've already navigated to the what's called now. Sorry, let me hide this. VS Code. All right. So you've navigated to the VS Code.
Excuse me, please.
You said?
Can you hear me, boss? Excuse me.
Go ahead. You can hear you, Wisdom.
Okay, please. I want to find out if you send your record to the
It's on the chat.
chat.
Check on the chat. You see it there.
I just logged in now.
Unless
so I
you're just
switched to my
joining so
phone,
they
my
can.
laptop because of the
All right.
Oh, okay. I'll send it again.
Hands-on.
I'll send it again.
Okay.
Okay.
Sorry, is the call also being recorded too?
Yes, the call is recorded.
Thank you so much. I think I've actually
All right.
I'm way back on
Wisdom,
this.
maybe you can leave your questions for after the session so we don't distract the session. You can go on, Kudus.
All right. Okay. Thank you. Okay. So if you are here, if you've navigated to your, let me do it by myself first. Okay. So I mean, if you have done your CD, DSA, HIV, so that means you have navigated to your what's it called, to your folder. Okay. Then it's always good to set up a virtual environment, right? And I would want you to do that. So just copy this, right? Paste it here, run it, okay? Then if you are using Windows, right? So copy this. If you are using Mac, copy this. And this is to create a virtual environment. This is to activate a virtual environment. Okay. So let me see if I have my own virtual environment. All right, I think I have my virtual environment. So so the name of my own virtual environment is my env, right? My env. So I have to rename this. Ah, sorry, what am I saying? Oh yeah, it's my env. Okay, so I have to rename this to my env. Okay. So now you see here my env. So that means it's activated. Okay. So now the next thing is that means you are here already, Abby. That's good. So the next thing is that you want to install your what's called your requirements, right? And those are the dependencies. You see here now, see requirement.txt. So these are the dependencies, and I mean they are the modules, the libraries we'll be using for this. See Langchain community, Langchain Google Gen AI, blah blah blah, all this. So so you have them here. So you now run your pip install requirement.txt. If you have them installed, it's going to tell you. If not, it's going to install them. See, I have them installed already. That's why I can see requirements satisfied, requirements satisfied, requirements satisfied, because I have them installed. If not, it's going to take time to install it. So now, very quickly, one thing I want you to do is Like I mentioned earlier, I said we'll be making use of Pinecone, we'll be making use of the Google Gemini AI. So the thing is APIs will be using, okay, because I don't want us to start downloading models here and there because that takes time. So I will be using APIs, right? So that will be very easy and they are free, so you can easily set it up. And I have, I think somewhere here, no, somewhere. Okay, all right. So okay, don't let us skip the step. So when you're done installing your requirements, and so I wanted to set up this .env example. So and these are the places you store your API keys. Okay, so we won't be going too much into engineering, but the essence is so that you don't add your API keys to your code. And people that have been vibe coding, if you're on Twitter, you see people adding their API keys to the code and they are losing a lot of money with that. So you don't want to do that. So you want to add it in a place where if you are pushing to your GitHub, it's not going to follow it so that people don't see your code. So and that's the .env. So you copy it here like this. So if you are using the code, is there already. So this is the .env example. You will not see my own .env. Okay, you will not see it. So this is the one you will see. .env.example. So you set it like this. These are the places you add your API keys. Okay. So when you are done adding it like this, you will now rename it to .env, not .env example again. It will be .env. This .env example is just for the sake of this project so that people can see how to set an environment variable. But I don't want you to see my API keys. That's why I'm not going to show you. So go and rename your own and add it like this. Okay. So now to get your API keys, come to the Google AI Studio. Where is it? This is here. It's not showing. Okay. All right. It's not showing anything. All right. This is my API key. Okay. So that means create your API. I mean, I think you have to sign up first. You can see me. I'm already signed up. So sign up, follow the process. It's very easy. If you have the Google account already, very easy for you. Then create an API key. Very, very easy. Then you get your API key. Okay. So when you get your API key, you add it here. Add it here like this. Okay. Then from the Pinecone, you do the same thing. Sign up, do all this thing. When you are done signing up, you also let me log in. Let me waste my time. But I thought I was logged in. Anyways, the point is that you'd see how to also you'll be able to get your API key from there. Okay, let's continue. So you can even see the steps here in case you're having issues doing that, but it's very straightforward. So you get your API key, you add it to this place. Okay. So are you there already? If you are there, let me see the action. All right, let me hope you are following. But it's, again, like I said, it's very easy. Okay. Um yeah, then the git ignore. Don't worry, I've set up everything. You have the git ignore, and that's to make the things you don't want to follow you don't want these things to follow your code anywhere. That's why I'm adding them, right? So your environment should stay locally, your .env should stay locally, and all this, just leave it like this. So so then the PDF I'm using for the sake of this project is this WHO, is a public data, so I got it on their website. So this WHO document, I got it on their website. So that's what we'll be using for this. And you see is in PDF. So so if you are going to be using your own PDF, okay, just change it. You can remove it and put your own PDF. It must be in PDF because of the structure of the code. Again, it's not as if it's only PDF you can use, but for this project, if you use any other thing apart of PDF, it will not work because of the structure of the code. So, and I'll show you what I'm saying. So, and if you add another folder, another file that has a different name in your code, you have to rename it. Do you understand? So you have to rename it in the code. I'll show you where. All right. So when you are done with that, and you've done that, so the next thing, like I said in the in the discussion that we had, that the first step is to store your data into what? Into the vector database, which is the Pinecone. So now this Pinecone vector py is the script we'll be using for that. So like I said, in the code, I already explained everything in the script, right? It's, if you are not very technical, you might have some issues understanding some things. But if you have some Python background, and I mean, there's always room to learn. Okay, so if you're interested, you can go ahead um, um, to learn more about some of this. But I'll just explain it briefly. So now I mentioned something about chunking your documents. So this is what we are doing here. So the chunk size here is 1500. Now this chunk overlap is to make sure that is going to like retain context, right? So like it implies overlap. So that means if you want to cut, you're cutting so you're cutting like the file now, but you want it to overlap so that the next chunk should start from like maybe 10% towards the end of the previous chunk, so it can be able to know the last information from that chunk and add it to his own chunk. So, and that's how it goes. So the next one also takes the last information from this chunk, add it to the next chunk. Do you understand? So, but you don't want to now overlap everything. So it's just bits that you want to overlap. So if the chunk size is 1500, probably the last 100 character is what you want to overlap. Okay, so that's the chunk overlap. So yeah, so that's the essence of this load.env is so you can be able to retrieve your environment, your API keys. So these are our embed model. Like I told you, we'll be using the Google generative AI. So it's actually let me go to the code. It's actually a Langchain. You can see it's from Langchain. Is a Langchain function, right? So they've synced it with the Google API so that we can easily use it here. So like I said, Langchain helps to simplify many of the processes. If not, we'll have to be writing so much code to do many of these things. But thank God we have Langchain. So easily we're able to like just call the embedding model, and this is the specific one we are using, this embedding 001. Okay, it's a free one also. You don't expect too much from it because it's free. So it's it's a very basic model, and it has 768 dimension, if I'm not mistaken. Yeah, I think it has 768 dimension. So yeah, that's 760 dimension. That's what this model has. So this is where you set up your Pinecone. The name of this index name is just the name of your vector database in your Pinecone. Do you understand? So let me see if this thing has logged me in yet. Okay. Okay, let's just restart time. So, but the essence is this index name is the name of the vector database you are setting on the Pinecone. So so here you want to create the vector database that we are saying, but before it does that, it's going to check. This is just like a normal process we do so that you don't duplicate your vector database, especially people that just keep running the script, probably because they're facing one or two errors. So this is to make sure you don't duplicate. It checks if the database exists before and it uses it. If not, it creates it. Like I said, is hosted on cloud, AWS. So I think they also have access for GCP. But just use this one. Like I said, I'm setting the region. If you're familiar with cloud, I think you would understand this. But again, just use it like that. Okay. So yeah, all these are just to limit your errors, especially that to be running through some errors if maybe you are using a very large data or a very large document and you keep getting the rate limit errors. So it's going to help you. It's going to like calm down for you and retry so that it does not tell you that it cannot do it again. It's going to calm down and retry. So that's just the essence of all those. So so now this is just to embed the document. Like I said, you don't just store your document there, you are going to embed it, and that's what all these are doing. So you are going to, so this one is to embed a large batch at the same time, right? So that your time is going to help you manage your time. So it won't be embedding one chunk or one documents per at a time. So it's be like it's going to embed it in batch, right? So so this is where I added. You can see is the name of my data. So if you are changing your data, so you have to rename it to, okay. So if I change it to HIV, I have to put HIV here, okay. So you have to rename your data if you are. So yeah. I think basically these are just calling the functions. Okay, so the batch size is like the size of document is embedding at a time. So this batch size is for the embedding. So upsetting means is like is sending the your embed is first of all going to embed your document, and it's now going to be sending your document to Pinecone by batch. Okay, so that's what this batch is for. So so yeah, so this is the function to send your embedded documents to the Pinecone. And once you do this very well, you are going to get, I'm not sure how fast this thing is. I don't want to do it again, right? But so the way to run the code is to do Python Pinecone. If you've done all this, make sure you have your environment activated. You've already navigated to the folder. The folder is DSHIV. So if you are using a different folder name, you probably want to change it. Okay. So if you've navigated here, then Python Pinecone. So Pinecone vector.py. This is just to run this file. You can see it's the same name, pinecone vector.py. So, but you put Python before it, Python pinecone vector.py. Okay. So once you do that successfully, it's going to run. When it's done, when it starts upstarting, it's going to tell you starting pinecone batch upstart. When it's done with everything, it's going to tell you pinecone vector storage complete. Okay. So once you do that and that's successful, then you're already a step ahead to become an AI engineer. Congratulations. Okay. Please, I still following. Please, I still following. All right, thank you.
Hey,
So,
sir, can you hear me?
all right, thank you. So, yeah, I can.
Oh, yeah, I was asking, like, I've seen that you are saying that we have to get an API of Pinecone. How do we go about that, kindly?
Yeah, okay. So, like I said, to get the API for Pinecone, you come here. This is the Pinecone website. You can see down here at the bottom left corner, www.pinecone.io. That's where this link here takes you to. So it takes you somewhere here. You sign up. I've signed up already, so you probably have to go through a longer. It's not long. It's a more long process than this. So this is just going to log me into the platform. So I don't want to take so much time, but let's see. So let me continue. I'll come back here when this thing is done. Okay, thank you. So, all right. So you can see my HIV. Sorry, you can see the HIV vector database here, right? So that's because like I said, I've created it before, so that's why I can see it here. If not, you will not see it. So you can see this is the dimension. So now you come back is if you don't have it. If you are just opening it for the first time. Sorry, if you are just opening it for the first time, is this thing you see? You not see anything here, right? You not see anything here. So come to API keys. It's not going to show it. Okay. Come to API keys. See, I have some number of API keys here already created. So if you are just creating your own, click on create API key. So name it whatever name you want to name it, right? So say HIV text 2, right? Then click on create API key. When you create API key, send this it. Hey, okay, you copy it like this. You can use it to I'll delete it now. Close it. So you copy it. When you copy it, you now go to your .env, then you now add it here. You delete this one like this, then you add it. Do you understand? So that's it. Then you save it, Ctrl S. That's it. Do you understand? So that's it. See me again. Okay. All right. So do you understand that? Sorry. All right, good. So let's continue. So where are we? Okay. So now when you're done observing, when you're done doing all this, we are done with them. Then you come to, let me click on it. Let's hope it won't take so much time. What's it saying? Search for that. Okay, see, I did not name it very well. Vector. I did not name it very well. Okay. So again, I don't know. It might take time. So let's continue. Let's hope. See, it's going to take time. Okay. It's faster. Wow, it's fast too. Probably because okay, it's fast actually. The document is not large, and I'm doing a batch of certain, so that's why it's quite fast. So you can do it. So that means if you are doing it, then you should be done. Abi. Let's continue. So the next thing then is to now run the app itself. So when you're done observing, that means your data is already in your vector database. You should be having something like you should have something like this. Do you understand? Check. You should have something like this when you are done. Go to your Pinecone and check your Pinecone. You should have something like this in your database under indexes. Okay. So once you are done with that, then the next thing is to run the app. So the app, this is the app like this. This is the main app, the one that has the Streamlit. Okay. So and what you are doing, like I said, you want, because you've already added the document somewhere, you want to retrieve, you want to send information and retrieve it, right? So that's what we're going to do. And to just briefly run through this again, you define your API keys here, right? So you also define your pinecone was called index. Do you understand? You know, the index name we give this HIV that you saw in the pinecone is here. You're using a different index name, you have to change it. Your embed model, you also define it. So now we have something we call a system prompt, and that's just like the let me say the default prompt that will always go with every question or every query that is sent. So and now you can see here is saying your name is HIV health guidance chatbot. You are a health advisor specializing in HIV. Answer questions very briefly and accurately. Use the following information to. So now it's saying use the following information to answer the user's question. Then it's adding the retrieved. Sorry. So is there anything? Can I continue? Okay, I
Yes,
think I should
let's
continue.
continue.
All right. So this is where you add this is where the document is added. The document that is retrieved is added. That means it's saying you should use this information in this document to answer the question. Okay. So again, this is just the basic way. There are several other ways you can do it if you are building for production. Do you understand? So and because sometimes your prompt might be probably wanted to think about a lot of things before doing this. You have a lot of things to tell the AI to consider before getting this one. This is where you specify them. Do you understand? So this is a very important part of your. So you should be good with prompt engineering. You should know how to write a very good clear prompt, and that's a very good skill to learn. Okay, so that's just a very basic prompt. Okay? So now this is the part where I wanted to generate the response. Okay, so it's going to first of all go and retrieve it's going to send the query to the vector database and retrieve it. Do you understand? So I want to show you where I added. So top K, this top K is what I was saying the other time that I said that okay, this top K is where I said I added it's going to determine the number of chunks or the number of queries that come or the number of top response to your question. Do you understand? So if you want it to be if you put one here, so it's only going to bring one most related response. If you set 3, it's going to be the top 3 most related response. Okay. So there are some things I didn't mention, but that are more if you want to be more advanced, there's something we call re-ranking. You can check it out. So it's just a way to make sure your documents are ranked well to a level where it can bring the most related response to your question better. Okay, so you can add a re-ranking step to the two steps I mentioned before. So I mean, you can check that out. But just for this basic project, this also works very well. Pinecone also has some inbuilt re-ranking to a large extent. Okay, so all right. So all these are just you know, so this gets all the documents, joins all the documents together, all the retrieved documents together. These are just like cleaning here and there. Sorry. So let me just let me stop my WhatsApp. Okay. Hopefully any code doesn't enter. So okay, so this is all these are just to okay. This is the again I mentioned that it's a conversational chatbot. So that means conversation means that it's going to retain the information you have before. So for instance, you say what is HIV? It tells you HIV is this. And the next question is then how do I treat it? It's not going to say, oh, I don't know what you're treating. That means it's not retaining the previous information, but it's going to say, oh, the way you treat HIV, because it understands that your previous question was actually HIV. So that's the essence of this. Before it can do that, then yeah, it has to have a history storing your information. Again, in production, largely in production, we don't do it this way, okay? Because this is just we are just using a session state, a stream it session state, right? So ideally, you should use a database for this. You should store it in an actual database. Do you understand? So that you because you have different users using it. So for every user, they have different conversation for each user. So that's why it's good to use a database. Do you get what I mean? But here now we don't have users signing up here, so it's just you that are using it. So that means this is just temporary, okay? So it's just going to be storing it in a temporary state. So that's the session state. Do you understand? So that's the history, but it's going to actually retain the history. Do you understand? So yeah, so memory, again, this works with the history. I don't want to waste so much time here. This prompt template is to create a pipeline for your system prompt, for your message placeholder, for your human prompt. This human prompt, so everything, all this, you see, this human prompt contains the question you're asking. Do you understand? So everything has to be sent together to the AI, to the model. Do you understand? To the generation model. I said there is the embedding, then there's the generation. So the model, the LLM that is going to help with your augmentation, you send everything to it together. So it's going to see your system prompt, see the message that you are sending, then see the history. Do you understand? The history, the previous messages that you've been sending, then the new message you're sending. This new message contains the retrieved documents as well as the question you're asking. So everything, you just send everything together to get the response. So I mentioned, so now this is the model you're using for this Gemini 2.0 Flash is our chat model. That's the model that is going to help with our augmentation generation or augmented generation. Okay. So you see, again, I want you to note that you could see that earlier is the same embedding model that I used. This same embedding model that I used, Abby, for that Pinecone is the same one in this Pinecone that I said. You see, it's the same embedding model, so it's very important. Okay, so where are we? Okay, so yeah, so you just pass all this again thanks to Langchain. That's why it's just as simple as 4 lines of code. You can easily just send it here. So this temperature, right, is where I said we'd be setting our degree of randomness. So, and this is important. If you don't want it to hallucinate, the range is from 0 to 1. That's the range. 1 means just hallucinate and be saying nonsense. That's the meaning of 1. 0 is that I don't want you to don't hallucinate. If you don't know this thing, just say you don't know. Do you understand? So it's always good to maintain this subjective anyways, but I work a lot in healthcare, and we are very careful with how we build our systems to make sure that the AI does not kill patients by hallucination. So we used to work with 0.1, 0.2 thereabouts. You understand? So most times I used to use 0.2 actually. I don't know why I put 0.1 here. So you can use, I mean, subjective, so 0.1, 0.2. I mean, I've seen 0.7. So it depends on what you want to do. So you can, again, optimization. When you test it once and you're not impressed by the response, you can change. So one thing to consider also is to consider your temperature. So many people, when they build systems like this, they don't know where the problem is coming from, because some people don't check temperature. So one thing that can actually be contributing might just build the nuisance to what you're building. This temperature alone can just mess up with your project. So you can always come back to this place and be changing it to, to be comparing with your response. Another thing to always check too is your prompt. You might be saying nonsense in your prompt, and that might be actually affecting your response. Do you understand? So those are one of the major things to consider. Then probably your document also, the data, the information in your document is probably not also good. Do you understand? Garbage in, garbage out. So yeah, we are done with this. When you get here, this is getting the response at this point. So you've gotten your response at this point. Okay. So now this is your Streamlit. This is where our app that we are building, the front end. This is where we specify our front end and how we integrate our front end to back end. This is Streamlit. So Streamlit is also easy to learn. I mean, you don't have to write Flask API, Fast API, write React Native, React JS, and whatever JavaScript to build an interface. Python is so shameful. We don't really have interface this thing. We do it backend. So Streamlit, we can use Streamlit for front end. Okay. So you can always tweak it. You can always tweak it. So let's run it. So to run it, instead of Python, whatever. So this time around, because we're using Streamlit, we're going to use Streamlit run. Now, because the file is main.py, if you're using a different name, you specify it here. So main.py. Now you pray. All right. Thank God. God has answered our prayer. Is running. See this guy running. He's just running. Okay. So now you can ask question and say, what is HIV? You understand? So ideally, it's meant to go to the document, query it, then augment it, and generate your response. Do you understand? So that's what it's going to do. So again, another thing to also, if you are not impressed with the response, another thing to check. I mentioned you can check your temperature, check your prompts, check your so check your temperature, check your prompt, and also check your model. Do you understand? You might actually be using a nonsense model like that. Do you get? So if you are not impressed, probably your embedding model is not good enough, your generation model is not good enough, or your data is not good enough, your temperature is not good enough, your prompt is not good enough. Those are like some basic things that can actually be affecting the quality of your app. So again, let's see if it's going to retain the information. So I will not say what are the features of HIV, I'll say what are the features. So that means I expect it to understand that I'm talking about HIV. So you can see the interface, right? So this is not backend, this is front end. All right, so it's able to understand that HIV, I'm talking about HIV. So I don't know why he's asking me this nonsense question. Supposed to know. Probably the document doesn't have the information. So, and again, because I'm using 0.1, you can see the information is bringing out too much like that. Does not see, it's asking question every time. It's asking question probably if I set it to 0.5, I'm very sure that it's going to just answer me like that, because the guy will just hallucinate and say whatever it is in his mind. Do you understand? But yeah, now because you can see 0.1, it's going to always want to qualify because it doesn't want to hallucinate. You can see what I'm saying. Do you understand? So yeah, so if you are here, you are at this stage, so you've successfully built a RAG chatbot, right? Can always modify it and make it better. So I think I would pause here for questions. Pause here for questions.
I'm sure you can see the reaction produced. Like, this was such an interesting session, and everybody's so excited about it. We're just going to, please, if you have questions, now is the time to ask your questions, because I think you did justice to the session. So please, you can just raise up your hand and we'll just take your questions and do that like in the next 10 to 15 minutes before we wrap up. Any question, guys? Please feel free to ask your questions now. And by the way, if you're asking if the recording will be made available, yes, the recording will be made available. There's also going to, I'm sure he would also share his slides as well. Okay, Byron, let's have you.
So thank you for the presentation. It was very interesting. I just want to ask, can we use the OpenAI LLM instead of using the Gemini LLM like you are using?
Yeah, thank you for the question. Yes, so like I said, I'm not promoting anything, but I'm a fan of OpenAI. Okay, so and I use OpenAI for my embedding model. They have their own embedding model. They also have their own the same way we are using Google's embedding model and Google's chat model. OpenAI also has their own embedding model, and they also have their own chat model, and it's very good. But you know the problem is not free. So if you are building the Lapo, you have to look for free APIs. Okay, so that's why we are using the Gemini. So yeah, it used to be free. I think I'm not sure. I've not checked if they have any free API recent, but as at 2023 or 22, we had free API keys that we were using to build them. But now they are proud now, so that's why. Yeah, does that answer the question? Yeah.
Byron, does this answer your question? I'm sure it does. Any other person wants to ask a question, please feel free to ask your question. I'm sure by the time we go back to the recording and practice this, we'll be able to get a full hang of it. But I definitely think Kudus has done great justice to this session. I mean, I'm not much of a DS, ML, AI person, but I was following and it was really, really interesting. Please, if you have any more questions, feel free to raise up your hand and then we can take your questions. In the meantime, I don't know if you have any other thing to add, Kudus, before we wrap up this session.
Okay. Thank you very much, everyone, for following through. So you can always go back to the repo and follow through, and tweak and tweak and tweak and keep learning. Okay, because it's a very dynamic field, and people are building amazing things, and there is no limit to what you can actually build with this. So yeah, it's a very good thing to learn, and it's been made easy. I could remember when I was trying to do something with the chat history thing sometime early 2023. I mean, probably I didn't know that they had at the time Langchain was also not so advanced, like, so, and it could be skill issues, but I had to write my own chat history myself, like by my chats buffering script myself. So things were kind of difficult. But now I think there's been a lot of development, and it's been really fun now. Like there is no limit to what you can build now. So this is the best time to actually learn these things and to build with these things. And when you build, let people help you if you have any issues. Then another thing I want to add is it's always good if you are aspiring to be an engineer, for instance. I used Streamlit for this, but it's just the case for the purpose of this project. So in practice, it's always good to use RESTful APIs, because you don't want to give your clients or the stakeholder, or whoever you're working with, the Streamlit app, because that's not what they use to make money. So you want to use a RESTful API, maybe fast API. People recommend it a lot because yes, it's kind of quite state of the art and it's very good. So that's if you are from the Python background. Yeah, I'm a pro Python anyways. So fast API is Flask, Django to write your and again, because as AI engineers, you don't really build front end stuff, right? So you would want to wrap it in APIs that the front end people are going to use. Those ones are the ones that will actually build the application, even if they want to. It can be integrated anywhere, probably WhatsApp, chatbots. It can be integrated into Facebook, Slack, into whatever chat platforms. They can also build it as mobile apps, as web application. You can see, it's really interesting, right? So that's if you build that as APIs, that's how they can be able to like use it anyway. Do you understand? So it's always good to learn these RESTful APIs platforms frameworks so that you can be able to build as much as possible. Then also you might want to learn databases, right? I use Postgres most of the time, so that works well too. For your database so that you can be able to store your chat history, store the user's information, your whatever information you want to store, so you can be able to work like build the history part well. What other thing to add? Then security too. You want to we use a lot of APIs, so you want to secure your API keys. You want to secure the user's information and all those. What else? I think basically that's it. And again, keep reading. Keep learning, because this the space is very dynamic. By tomorrow, you just see they've launched another thing that you need to learn, right? So just keep learning. Yeah, I think that's all I have to add. Thank you.
Definitely keep learning, you guys. Like, the field is evolving, and there's always something to learn. There's always something to actually add to whatever knowledge. There's always something new in the field. So you just have to stay updated and evolve as the field is evolving. I want to use this opportunity on behalf of the entire Data Community Africa team to appreciate you, Kudus, for honoring our invitation and for taking this session. I'm sure everyone has learned a lot. We really appreciate the time. And for everyone that stayed on the call to this time, the recording is going to be available on the YouTube. I already dropped the link. By the end of today, or latest by tomorrow, it should be up on there and you would have access to it. I'm also going to reach out to Kudus to see if we can get his slides in case you want to do further reading. But thank you all for sticking to this time. Till our next webinar, I'll see you guys then. Have a lovely evening. Good night, everyone.
Thank you. Good night. So.
Thank
Yeah,
you.
thank you. Good night.